In this lecture, I will present the how to identify the traffic or how to analyze the network traffic and how to distinguish between the genuine traffic and abnormal traffic. So, as part of this, first I will discuss the how to identify the genuine traffic. So, anyhow, in the last lecture, we have seen the common vulnerability exposure database and how this will be useful for writing the signature patterns. And now I'm going to discuss the how to identify the how to distinguish, first of all, what is the genuine traffic and what is the abnormal traffic. So anyhow, this is the figure 2 CVE candidate listing CVE 2012-0390. This is the vulnerability number which was listed in 2012. So here this is the description, and a clear-cut description was given, and supporting references and this kind of things were given. Anyhow, this is required for our intrusion detection and prevention system because to maintain the signature database. Now we'll move on to the understanding of the signature analysis. So signature is nothing but set of characteristics used to define a type of network activity. Like for example, IP number and options, TCP flags and port numbers are some examples that we'll try to inspect so that for any malicious activity is initiated by the attacker or not. So that means you need to understand in our analysis in general, we always focus on the IP numbers, options, and TCP flags and port numbers. So these are the main components that we'll always inspect. The reason is, if for example, synchronous flooding or denial of service or source quench, these kind of things will happen because of the flags. Okay, so that is the reason in the previous lectures we have discussed main protocols that will work at the data link layer, network layer, transport layer, and the application layer. So at the application layer, we have seen DNS, in the transport layer, TCP and UDP, and in the network layer, IP and ICMP, and at the data link layer, ARP protocol. Some intrusion detection devices assembles databases of normal traffic signatures. So if any deviation from the normal traffic signature, then automatically that will raise an alarm. Other devices refers to a database of well-known attack signatures. Traffic that matches stored signatures triggers an alarm. That means maintaining of normal traffic signatures, and if it finds some abnormality, then immediately raising. Or already loading with the abnormal signatures, and if a pattern was matched, raising an alarm. So two categories are there in IDPS. We can configure the IDPS in such a way. So signature analysis here, practice of analyzing and understanding the TCP/IP communication to determine whether they are legitimate or suspicious. So in order to understand signature, first you must have a strong hold on the TCP communication, TCP/IP communication especially, in which what are the things we will check for? Not only IP addresses, port numbers, and TCP flags, etc., but also we'll check for the bad header information. Packets are often altered through the header information. When the header information is changed, then its meaning of, or its related what you call purpose will also change. Suspicious signatures can include malformed source and destination IP addresses, source and destination port numbers, IP options, protocol and checksums, IP fragmentation flags, offset, and identification. So these are the main components that we are supposed to check in case of suspicious signatures. In this, we'll see one component by component. Checksum means nothing but checksum will be calculated at the time of package creation. That means a mathematical formula will be applied on the header so that some output will get. That output will be placed in the checksum, and the same mathematical formula will be used by every point, so that they will recompute this. They will recompute this checksum at every point and compares with the checksum which is already present in the header. If both are matched, that means they will come to no conclusion that nothing was changed in the header information or in the packet, so that this packet can be passed further. This is the way the general understanding of the checksum will be there, and determines whether a message has been damaged or tampered while in transit will be determined by this checksum. And this checksum can also be inspected at the IDPS level. Suspicious data payload, again payload actual data sent from the application on one computer to another application on another computer. So some IDPSs will check for specific strings in the payload. Some specific strings. Why is that? What is the meaning of this? Is these specific strings will convey some meaning. Okay, we'll see afterwards what is these specific strings are. They will convey some specific meaning, and every string will be having their own meaning. And thereby, what will happen if there is a change in the string, then automatically the meaning will be changed, and the functionality at the receiving end will also change. Remote access trojans, especially open backdoors that gives the remote attackers the administrative rights. So they also these kind of things, for example, will be having different strings set in the payload. Next is, for example, Unix send mail program is exploited by adding codes to the packet content. This is an example we can say. During this way of sending the suspicious data payloads, attackers used to choose two methods. One is single packet attack. Second one is multi-packet attack. Single packet attack is nothing but only a unique packet or atomic packet will be sent with wrong or suspicious data information. That is what the suspicious data payload information in the single packet. That is called single packet attack. It is also called as atomic attack, single packet attack, completed by sending a single network packet from client to host. If one single packet was sent and received at the host at the receiving end, that's all. It itself will launch an attack. That is what the called single packet attack. Does not need a connection to be established, but just by simply sending this packet, like changing to the IP option settings can cause a server to freeze up. Okay. The IP options like this: end of option, no operation, security, loose source and recording, record routing, internet timestamp, record return route. As I told you in the morning session, okay, the recording of the return route. Application options has been deprecated, strict source and record routing. These kind of options, setting the power options may sometimes freeze the server. Multiple packet attacks, also called as composite attack. Within one packet, only with one packet, attack will not be happen. But the IDPSs at the receiving end has to inspect several packets to discover the attack. Requires a series of packets to be received and executed for the attack to be completed. Especially difficult to detect this, because one packet may come at one time, another packet may come after some time, another packet may come after some time. You may surprise that how this thing will be assembled. Just like you recall the fragmentation, where this is not the ending packet and some more packet has to come. So automatically the receiving end, what they will do is what the device will do is it will create a buffer and will wait for the next packet to come. Like that, the packets will not come in one stretch. So like that, they will maintain some time gap, some irregular time intervals, so that it should be remain undetected from the what you call sensing devices or security devices at the network perimeter. Example here is denial of service attack, or obvious examples of this. ICMP flood, a type of denial of service attack that occurs when multiple ICMP packets are sent to a single host on a network. Server becomes so busy in responding ICMP requests that it cannot process other traffic. So these are some examples that a multi-packet attack. So how this single packet or multi-packet attacks will be detected? It will be detected with the help of the packet sniffing. Packet sniffing is nothing but extracting or getting the copy of the network traffic that is going on the network channel. So capture the information about the TCP/IP packet it detects. Capturing the packet and studying them can help you better understand what makes up a signature. The best example is you may use Wireshark or T-Shark or TCP dump. Like that, you have many options of open source sniffing tools available. Among all these things, Wireshark is one graphical user interface with a proper graphical user interface, and for analysis purpose, we may use the Wireshark. In this course also, I will use the Wireshark and TCP dump for explaining this packet capturing. Be familiar with the elements of TCP/IP packets. So that means you must thoroughly know the packet structure and the options of the TCP/IP packets. The example is like this here. This is a ICMP example, ICMP echo request packet capture example in the Wireshark. So here Internet Protocol version. If you double click on this Internet Protocol version, then you will find the Internet Control Message Protocol, in which you will find the type 8 is echo request, and code is 0, checksum is this one, identifier and sequence number, its related information will be found here. So with this echo number, whatever echo number you have identified, that is code bit, with which you can identify that whether it is a genuine packet of ICMP type or not. So this analysis must be done with the help of the sniffing tools. But the prime requirement for any sniffing tool to be used is the sniffing tool should always work in the administrative privileges. Normal user privileges may not be sufficient for getting the traffic. And that means first requirement is the sniffing tools like Wireshark or something must work using the administrative privileges. That is first requirement. Other than this requirement, the first and foremost requirement, we can say this is second requirement. The first and foremost requirement is the network interface must be turned to the promiscuous mode. You have to make note of this promiscuous mode. Promiscuous mode is nothing but tap mode. In the previous lecture, we have seen tap mode is nothing but communication will go on. Okay, communication will go on, but a copy of the communication will be sniffed by the sniffing tools like Wireshark. So always the network interface card must be turned on. That is, promiscuous mode should be turned on. What is the advantage of this promiscuous mode? Usually, assume that in any network there are 20 computers or 30 computers are there. If a packet is going to a specific computer, maybe 30th computer, but every computer can listen to it. Every computer can have the capability of listening to this packet, but they won't take that packet. The reason is because of the ARP. Okay, because of the ARP. So that means this packet will be given to the computer who qualified the physical address or who is with the physical address requested by the switch. Only that physical address can receive it. But everyone in the network can sense it. The reason is whenever you turn on the promiscuous mode in the network interface card, it can listen to every packet, frame, everything which is going on the traffic. But if you turn off the promiscuous mode, in general, the network interface card will receive only the packet what it is intended for. That is, the packet which is intended for the particular computer will be received by the network interface card. That is what the difference between the network interface card in the promiscuous mode and in non-promiscuous mode. So that is the reason always the promiscuous mode must be on. Then only you can listen to the traffic which is going on the communication channel. That is the first and foremost requirement for usage of the Wireshark or any other sniffing tools. So you may install Wireshark and you may not find some traffic there. The reason is that this is the only reason. Okay, in textbooks and all you will find, okay, even though your IP address is not a specific IP address, but the Wireshark is showing some other IP addresses How is it possible? Means the network interface card must be turned into the promiscuous mode. That is the first and foremost requirement. The second requirement means that should be operated in the administrator mode, that is our root mode. So that is the reason whenever you work in the Linux operating system or something, like you will say sudo Wireshark, then only you can be in a position to capture the network traffic. So these are the two requirements that you must remember when you go for choosing of the Wireshark for sniffing the packets. Now we'll see the analyzing of the traffic signatures. Need to detect whether the traffic is normal or abnormal. This is very, very important. As a security engineer, you must be thorough with scrutinizing or categorizing whether the traffic is normal or abnormal. So for that, you have to make a network baselining. Process of determining what is normal for your network before you can identify the abnormalities. So that means whenever you list out this is normal, okay, whenever you list out this is normal, then automatically whatever will happen other than this will become abnormal. So in general, what is the normal behavior? The student will come and will enter into the class and he will sit, he will listen to the class and will go, okay. But what is the abnormal behavior? Okay, he will rush into the class, okay, and he will disturb the environment. So this is what the abnormal behavior. That means whenever you list the normal behavior, then automatically whatever will happen against that will become the abnormal behavior. So in order to do that, first of all, you have to examine the network traffic signatures. Again, the same concept that what we had discussed during the packet analysis or packet format discussion will come into the picture. The important TCP flags that need to be remembered, all are represented in the hexadecimal form. Synchronous flag means 0x2. Synchronized flag is sent when a connection is initiated. During the Wireshark traces, you will find this kind of signals: SYN, ACK, PSH, URG, RST. And you may not directly find this, but however, you will find as a hexadecimal form. Like how you have identified here, type is equal to 8 and code is equal to 0. Some checksum is equal to in the hexadecimal format, which is incorrect. So like that, how you will identify an integer format or maybe a hexadecimal format, like that you will find in the traces. So ACK flag is nothing but acknowledgement flag. Is set to signal that his previous packet was received. PSH flag is for the push flag for immediate delivery of the required packets, even though in an irregular order. URG flag is used for urgent data being to be sent. RST is for the resetting of the connection. And finish flag is for the finishing of the finishing of the connection establishment. Finishing of the connection. Sending the information. Finishing of the sending the information. So placement and use of these flags are definite. Always you have to use a fixed format for representing these flags. So deviation from normal use means that the communication is suspicious. It's very simple. This is the code set. This is the flag set. You must remember thoroughly. SYN, ACK, PSH, URG, RST, and FIN. So when there is an abnormality in this, when there is a disturbance or when there is an improper way of arranging the signal, then automatically you can assume that the communication is suspicious. Here is a simple example of T-shark capture on the TCP stream. See, the T-shark, Wireshark, all are of the same type. All will use the PCAP packet capture as the base program and will capture the packets. But the only thing is the user interfaces and these kind of things are different. So here, in one more thing is in the packet sniffing tools, you can choose whatever the field you want. Here the field selected are like this: sequence number of the packets that is captured, seconds from packeting of the, packet capture, source IP, destination IP, protocol, size of the packet, source port, destination port, and the flag type. You look at here, there is a IP address like 192.168.1.132. From source IP of 132 to 1, a TCP signal is coming, like with the synchronous signal. Okay, the synchronous signal is sent. That means the 132 is trying to establish a connection with the 1.1. Now 1.1 has replied with the synchronous acknowledgement, SYN ACK. Then 132 to 1 that is 132 to 1 an acknowledgement has been sent. That is acknowledgement to the synchronous acknowledgement. And one more thing is, if you can observe, if you click on this and you can see what is the sequence number, okay, what is the sequence number, what are the flags set in that, this kind of thing, information you can find by clicking the corresponding trace. Like that, the connection is going to be established and the data has been sent, okay, and the 132 has sent the acknowledgement signal, and in case of 1.1 has sent the PSH signal, push signal, and here finally 1.1 has sent the finish signal. So this kind of thing you can observe via traces, and these traces will be used by the IDPSs also. Even in not IDPS also, they will use this packet capture. And whatever the rules you write, they will be tested against this packet capture. I hope you got by this time the importance of the packet capture that need to be understood. Examining the normal traffic with the FTP signatures that we look at. FTP in general will use the TCP protocol in the transport layer. Organizations that operate a public FTP server should regularly review the signatures of the packets that attempted to access the server. Normal connection signatures include three-way handshake, just like that is sending of synchronous signal, synchronous acknowledgement, then acknowledgement to that. The sequence of packets are shown in the next slide like this. Here, 192.168.1.32 is sending the request to the 110 for establishing a TCP connection of 21. That is, a request is coming from the 50580 port number to 21. 21 is nothing but FTP. FTP is the internal default protocol port number is 21. A synchronous signal has been sent. And from 110 to 132, from 21 port number to 50580, synchronous acknowledgement has been sent. Now from 132 to 110, acknowledgement has been received. That means now this connection is established. Once the connection is established, just before connection, once the connection is established, then 110 to 132, the FTP. Now the FTP packet, that is FTP server application, is coming to the picture, and with the packet size of 81, and response is of 220, which is the application that is used here is Microsoft FTP service. The Microsoft FTP service as the application which is at the application layer is making use of this connection. Now when there is any file transfer or something was happened here, then it is sending an acknowledgement signal. So this is the way the FTP connection is established and the data transfer is taking place between the requester and the server. I hope by this time you got the pattern analysis, how to get the patterns. And one more thing is, here you have seen the pattern structure here, but one thing you remember is you may not find all these fields in the Wireshark when you open for first time. You may find or may not find. Okay, in general these things will be found, like the sequence number, this is sequence number of the Wireshark trace, and this is the time, source IP, destination IP. This is in general you will find. So in the view and filters, you may check or uncheck, or you may create some new filters for showing onto the graphical user interface. Like that, you can filter out or you can figure out whatever the fields you want for network traffic analysis. So that you must remember when you use the packet traces. And this is the beginning of the FTP session, then continuation of the FTP session. Once the Microsoft FTP service is on, and if the acknowledgement has been received, then if anyone is accessing a particular directory, FTP directory, which is a password protected directory, then continuation of the FTP session will be like this. The port that is IP address 192.168.132, 132.110. FTP request is going on with the user as a Dean. Now the 110 is asking for response to enter the password. So that is the password. Response is 331. That is the application code. That is giving you 331 as the code, as the response code. What is the response code of 331 is password required for the user, Dean. Then 132 to 110, then the acknowledgement has been sent. That means, okay, I have received your request. Then from 132 to 110, the request, the password has been sent. Now if this password is not encrypted, then you can easily trace it via Wireshark. If it is password is encrypted, then the encrypted information you will get, either it is MD5 information or the encryption format is MD5 or SHA1, this kind of thing will come. Usually the attackers, what they used to do is, once they get this information and once they get the encryption information, that is hashing information, then immediately they will use the reverse hashing websites or reverse hashing tools, or they may place a dictionary attack or maybe a brute force attack to know the password information. Okay, so this is the way the attackers will also use the Wireshark. It is nothing but we should not assume always that only the army and police will use the arms, but the same arms may also be used by the dacoits and the thieves. Okay, so that means Wireshark is a good tool. You cannot say that Wireshark can be only used by the security people. Wireshark will also be used by the attackers in their own way. That you must understand. I hope by this time you clear, okay, what is the need of this Wireshark and all. Now the 110 is sending a request to the sending the message to the 132 as a response that the user Dean is logged because the password is successfully matched. So this is what the reply will come from the FTP. Then now the file transfer and all will go on and all, but the user Dean want to stop this FTP connection. Then whenever FTP connection has to be teared down, then automatically you have either the requester or the client has to send the finish signal. Whenever the finish signal has been sent, then the server will come to know that the data communication or data transfer was completed, and the user wants to terminate the connection. This is what the understanding in general. So that is reason 110 is sending the message to 132 saying that finish acknowledgement. Then 132 will send a request to the 110 as an acknowledgement. Then for the acknowledgement of the finish, again finish acknowledgement will be sent by the 132 to 110. Then 110 is sending acknowledgement signal that okay, I have received your finish signal. Then completely finishing of the connection, and thereby the connection will be disconnected. So this is the way tear down of the FTP data connection. This is a regular way of happening of the connection. Now think of if any traffic is coming in an abnormal way other than this regular pattern, then we can say that is an abnormal pattern. Okay, that means as a security engineer you must understand the regular pattern of the traffic. Then only you can judge what is the irregular pattern. That is what the intention of this lecture, that is normal traffic signature analysis. This is generally TCP based, and web signature analysis like this. Most of the signatures in the log files are web related. When a signature is web related, it consists of packets sent back and forth from the web browser to the web server as the connection is made. In general, in order to resolve any web related request, if it is a domain name, then automatically the domain name service will come into the picture. In the previous lecture, we have seen to get the web page of the vulnerable OS v2 web application, we have directly typed the IP address. Whenever the IP address was typed, who will come into the picture? Obviously, the ARP will come into the picture. ARP will ask who is the IP having this particular, who is the system having this particular IP address. Then in response to that, ARP will work. If it is a website name, then automatically DNS will work. Okay, DNS will come into the picture. So the DNS will DNS will come into the picture, and DNS will ask for that is what is the corresponding IP address, and DNS will take care of the IP address resolving, and finally the website will be appeared. The normal communication consisting of a sequence of packets distinguished by their TCP flags. Here is an example. 132 is sending request to the 65.54.87.10, which is a public IP address. Okay, that is the HTTP request. That is the reason on this port, on this IP address, 80 port is going to be linked. And for this, synchronous signal was sent, and whenever synchronous signal was sent, then whenever this IP address is received, it is the responsibility of the resolver to ask for who has 19.168.1.132. Okay, and it will ask the router, or it will ask the network ID who is having this particular 19.168.1.32. Then in response to that, ARP will come into the picture. Now the ARP will send back the physical address of the corresponding IP address. So when the physical address of the IP address was sent back, then automatically the 65.54.87, that is the public address, whatever the response sent by the public address will be received at the local address 19.168.1.132. Okay, then that is synchronous acknowledgement signal. Now synchronous acknowledgement, in order to respond to the synchronous acknowledgement signal, obviously that 132 has to send an acknowledgement back. Then only the connection will establish. Now in the previous FTP, we have seen the first one, first, second, third, and here fourth one. First one, fourth one, and fifth one. Okay, but this is not happening. The reason is here the communication is happening between the web browser and web server. So the web server wants to resolve the IP address with respect to the physical address. For that, it is taking the help of the ARP. The ARP is resolving the physical address whenever it knows the IP address, and it is asking to the network that who is having this IP address. Okay, send their physical address. So whenever the physical address has been sent, then corresponding request has been forwarded to the corresponding IP address. Then IP address in turn will respond to the requester as a synchronous acknowledgement. Then the connection is established. So this is what the normal way of doing. In this, ARP will also come into the picture whenever you go for communication between the web browser and web server. And once the handshake is completed, web server sends the request to the web browser, request the web server for web page. Then HTTP data get packet will be collected. That means your HTTP is using get packet, automatically get and whatever the information is transmitting on the communication channel, that will be displayed onto the Wireshark traces. And that if that is a sensitive data like the password information, such kind of things are available in the get information, immediately attacker can use that data and may perform the launching of attacks. So this is the way you are supposed to first you need to identify what are the normal signatures. Then we need to go for identification of the abnormal signatures. The abnormal signatures in general will be identified with the categories such as informational, reconnaissance, unauthorized access, and denial of service. We'll see how to understand the abnormal signatures in the next lecture.